Yes, today's topic is limit. What is called a limit of a function? Before starting the definition of limit or how to evaluate the problems of limit of a function, let us see a simple definition of neighborhood. Generally, we know what is called neighborhood. Neighborhood means the people living around you. But in case of mathematics, neighborhood means the numbers available to you in particular periphery, or you can say, if you're looking for the neighborhood of 3, that should be very, very, very small. Means if you're saying that the neighborhood of 3, you're writing it as, okay, this is from say 2 to 4, but this is very large. You have to avoid such a big neighborhood. So if you are talking of the neighborhood of 3, that should be very small. As I have written here, it's 2.9999, and you keep writing 9 a lot of many times, comma 3.00001. So this is a very small neighborhood of any number. In mathematical terms, we should write it as 2 minus epsilon to 2 plus epsilon, where epsilon, this is epsilon. Epsilon is a very, very, very minute number. And keep one thing in mind, that limit is always defined in the neighborhood of a number. If this is the neighborhood of 3, and just see 2.999 and so on up to 3.0001, this also contains the number 3. So if I delete 3 from here, then this becomes the neighborhood of 3, a deleted neighborhood of 3. So similarly, I have written here the deleted neighborhood of 2 is, neighborhood of simple 2 is 2 minus epsilon, 2 plus epsilon. If I eliminate 2 from here, that becomes the deleted neighborhood of 2. So limit is always defined in the deleted neighborhood of any number. Now this is the definition. This is basically for the people who are very much engaged in mathematics, not for the people who are simply taking mathematics as a subject for their qualification, completing of the qualification like BC, PB, etc. They need only to go for the method of evaluating limit. But what actual definition of limit is? L is said to be limit of a function fx as x approaches to a, if for every epsilon greater than 0, a very small number, there exists another small number delta, such that distance of fx and L is less than epsilon. This is less than epsilon for all x minus a less than delta. Now what is the meaning of this? Suppose we are looking for the limit of x square minus 4 upon x minus 2. Now in this case, if you put directly 2 here, it will be 4 minus 4, 0, and this is 2 minus 2, 0, and 0 by 0 is undefined. So to find a limit, what I do is I keep using the formula of this x square minus 4. The identity you have is x minus 2x plus 2, that is a square minus b square is a minus b a plus b. And you can see this factor will cancel down. You will be left only with x plus 2. So this becomes limit x goes to 2 of x plus 2. So if you put 2 here, it becomes 4. Now what the meaning of this definition is, just see, I have made a table over here. Yes. When you are approaching 2, means you are going close to 2, that means you can go from the left hand side or you can come from the right hand side also. Left hand side means left of 2, that is the numbers, say 1.8, 1.9, 1.999 and so on. From the right hand side, you can say from 2.1, 2.01, 2.001. Now see, we are here. This is the place where you put 2 or substitute to 2 here. That becomes 2 plus 2, 4. Suppose I am at 1.9. I am in the neighborhood of 2. If I put 1.9 here, I will be getting the value as 3.9. If I am putting 1.99 here, it will be 3.99. Similarly, from the right hand side, if I am coming, this is 2.001. We put 2.001 in place of x here. You add 2, that becomes 4.001. Similarly, for 2.01, it becomes 4.01. And for 2.1, that becomes 4.1. See here, when you are approaching to 2 from the left hand side, or you are approaching to 2 from the right hand side, just see this number, the value of fx. This is approaching to some number. From both the sides, from left hand side as well as the right hand side. Now where this is approaching? This is approaching to 4, and that's why this is called 4 as a limit. See the definition. I say modulus means distance of fx and L. Fx means the function and L means whatever the answer you're getting for the limit. This distance becomes very small. You can see 3.94, 3.9924. This distance is becoming very small as the distance of x and where you are approaching to becoming small. As the distance between x and a decreases, the value of function is going close to some number, and that number we call it as the limit. And if you're approaching from the left hand side, we call it as a left hand limit, and if you're approaching from the right hand side, we call it as a right hand limit. Now, what basic thing you have to remember and what your intention should be while evaluating the problems of limit? While putting the value of point in the function where you're finding the limit, where we are approaching, we have to avoid 0 in the denominator. If the denominator does not become 0, then substitute the value. I'm saying, you can see here, in this example, if you put 2, we are approaching to 2. If I put 2 directly here in the denominator, this is 0. Now this is the problem we have to eradicate. Once this problem is eradicated, you will definitely get the answer. In case, suppose it's instead of x minus 2 here, it is x minus 1, suppose, in the denominator, and you are approaching to 2. If you are putting 2 here, it will be 2 minus 1. That is 1, which is non-zero, so you can directly put the number. There is no issue at all. We have simply to use the formulas, whatever the other methods are, only in that case when we are getting the denominator as 0, not otherwise. I think I have made an example also. Yes. You can see this example. This is limit x goes to 2, x square minus 1 upon 3x minus 2. Now, if I put 2 in the denominator, it will be 6 minus 2, 4. Now, this is non-zero. You go ahead. You simply put the value of 2. You put 2 here. It's 2 square, 4 minus 1, 3. It's 2 here. 3 to the 6 minus 2, that is 4. So, you're getting the answer as 3 by 4. Or one more example I have written here. Limit x goes to 5. Now you can see the denominator. If I put 5 here, this is 15 minus 2, 13. That is non-zero. Go ahead. You put 5 here. It is 25 minus 25, 0. Now 0 in the numerator doesn't affect any number because it is defined. 0 by any quantity is always 0. But something upon 0 is not defined. So we have to avoid the 0 in the denominator. There is no issue in case of numerator if it's coming. So this is 15 minus 2, that is 13. It's 0 by 13. This is 0. You got a limit. Now let us see in this example. This is x square minus 16 upon 3x minus 12. If I put 4 here, as x is approaching to 4, what happens for denominator? It's 12 minus 12. This is 0. Now this is the problem. This is what we have to avoid, or we have to use some methods to evaluate the limit of this very function. Now this is, I have mentioned the same thing. What is left hand limit and right hand limit? In case you are approaching from the left hand side, in case of limit x goes to a, if x approaches to a from the left hand side or from x less than a, then we call it as a left hand limit. And the notation we will use there is limit x goes to a negative. We put negative in the superscript. That doesn't mean we are putting minus a over there. We will put a as it, but we will put a superscript as negative. That means this represents that we are evaluating the left hand limit. And if your x is approaching from the right hand side, means from the right side of the number a, when x is greater than a, then we call it as a right hand limit. And as we have used negative in the superscript for left hand limit, we use positive in the superscript for right hand limit. And keep one thing in mind, the limit of a function exists only when we have limit x goes to a negative is equal to limit x goes to a positive. Means left hand limit and right hand limit, if you are evaluating in any problem, if they both turned out same, then we say the limit is going to exist. In case we are getting the different values for these two numbers, that means the limit does not exist. Now these are some methods how you have to evaluate the limit. First is by use of the formula, as we have done in the last example of x square minus 4. I'm talking of this one. Yes, we have used here x minus 2x plus 2. This is identity we have used so that the factor which is making 0 in the denominator should cancel down. So this is also one of the method, that is by the use of formula, or this is also you can say by factorization. That is a similar thing. Then one is by substitution, and other is by the use of binomial theorem. But as I've told you, for the people who are simply studying mathematics as one of the subject for their higher classes, for them it's better you remember simple formula that limit x goes to a, x raised to power n minus a raised to power n upon x minus a. This is directly equal to n a raised to power n minus 1. You can use directly this formula over there. And as far as the trigonometric expressions or limits are concerned, this is a single formula which is mostly used in all the evaluation of limits, that is limit x goes to 0 sin x upon x. This is always equal to 1. Now let us see some problems that will make the concept more clear. Yes. Now this is a problem. This is, we have to evaluate limit x goes to minus 2, x square plus 5x plus 6 upon x plus 2. Now see, first of all, the very first thing you always will check is whether after substituting this number, we are getting 0 in the denominator or not. If you are not getting a 0 in the denominator, then go ahead, put the value, you will get the answer. But if you are getting 0 in the denominator, then we have to do something. Now see, minus 2 we are putting here. This is minus 2 plus 2, that is 0. So I am searching for a factorization of this number. That is by splitting the middle term. The factors will be x plus 2 into x plus 3. And you can see x plus 2 will cancel down. You will be left only with x plus 3. Now you can put here, because nothing is in the denominator. When nothing is there in the denominator, that means it will be evaluated simply. You put minus 2, it's minus 2 plus 3, that is 1 is the limit. One more example. Now this is, we have to evaluate limit x goes to 1, x cube minus 3x plus 2 upon x cube plus x square minus, it's 5x, not x. Let me make the correction here. Yes, it's 5x plus 3. Now let's put 1 here. This is 1 plus 1, 2, 2 minus 5, minus 3, minus 3 plus 3 is 0. That means we are getting 0 in the denominator. And secondly, let's do one more thing. Let me put 1 in the numerator also. This is 1 minus 3, minus 2 plus 2, 0. That means if x minus 1 is a factor of this, x minus 1 is also a factor of this. Now, this is 0 by 0 form. So what I do is, I divide the numerator and denominator by x minus 1 by long division method. After the division, I am getting x minus 1 as a factor. And the numerator, the quotient is x square plus x minus 2. And whereas in the denominator, the quotient is x square plus 2x minus 3. Now let me cancel this number. I am getting these two numbers now. Let me again check whether the denominator is 0 or not. If I put 1 here, yes, this is 1 plus 2, 3, 3 minus 3, it's again 0. That means still x minus 1 is the factor of the denominator. Let me check the numerator also. 1 plus 1, 2, 2 minus 2, again 0. That means still x minus 1 is a factor of numerator as well as denominator. I have substituted the values also here. This is 0 by 0. So again I am trying to cancel this factor of x minus 1. After factorization of, by splitting the middle term, I am getting the factors as x plus 2 into x minus 1 upon x plus 3 into x minus 1. Now this x minus 1 will cancel down, and we are getting the numbers as in the numerator is x plus 2, the denominator is x plus 3. And you can see in the denominator, if you put 1 here, 1 plus 3 is equal to 4, which is non-zero. So now we can substitute the value. It will be simply 3 by 4. Let's go for the, yes, this is also one of the method we can add. This is by the use of rationalizing. Let me add the method here. By rationalizing. This is used when you are having a square root or somewhat like that. Yes. Now in this example, we need to evaluate limit x goes to 0, square root of 1 plus x minus square root of 1 minus x upon x. Again the same thing. First of all, check denominator. It's x only and x goes to 0, so this becomes 0. So what we do is we use rationalizing here. And the factor by which we rationalize is, this is the number of square root. Whatever the sign you are having here is, where my cursor is, if it is negative, you rationalize by positive. If it is positive, you rationalize by negative. So it's negative here. I rationalize the things by positive. The same number I am multiplying and divide. Now in the numerator you can see this is say a minus b. This is a plus b, that is a square minus b square. I use identity here, and rest as it is. Rest means x as it is, and this denominator is again as it is. So after calculation that becomes 2x by this x as it is, this number as it. Now this x will cancel down. This is the problem we are facing now when we are putting 0 here. After cancellation of x we get 2 here, and yeah, now you can put 0. With 0, this is 0. But you are getting 1 plus 0, 1. Root 1 is 1. 1 minus 0 is 1. Root 1 is 1. So this is 2 by 2. That is equal to 1. So this is the limit we are getting. Let's go for, I have taken a single example for all the types of limits. Now this is limit x goes to infinity, x cube plus 5x plus 8 upon 2x square minus 3x plus 3. X goes to infinity. Now in case of infinity, when limit is approaching to infinity, we have to remember what we do is we have to take the maximum degree common from the numerator as well as from the denominator. Now from the numerator, this is you have 3x square plus 5x plus 8, maximum degree is 2, denominator is also 2. So I have taken x square common, we left with 3 here. This is 5 by x, this is 8 by x square, this is 2, again x square common, minus 3 by x, this is plus 3 by x square. Now if x goes to infinity, something over infinity is 0. So this becomes 0, even this also becomes 0. Better to write the values here. This becomes 0. This also becomes 0. 0. This also becomes 0. Yes. X square will cancel down. If I put x goes to infinity, it will be something upon infinity 0, again 0, 0, 0. This is only 3 by 2. Now you can see one thing here. If the degree, highest degree of numerator and denominator is matching, then we are getting the coefficients as the limit. You can see here is 3 by 2. In case the degree of numerator is more than that of the denominator, you can see here this is 2 and 2. We're getting the coefficient 3 by 2. If it is suppose it's x cube here. Let me add the numbers. Say this is cube here. Let me copy this to keep one more example. Yes. Let us suppose we are having cube here. Keep this as x, nothing special about it. Say this is also cube. It's not so clear. I'll make it clear in word window. Let me first of all just write the numbers. This is square. This is 3. Now this is actually getting infinity. I need to use the symbol here. Yes, just like here. Now see. Suppose the degree of numerator is cube 3 and that of denominator is 2. So I have to take the maximum common. I have taken cube common from here. So you are left with 3 plus 5x square plus 8 by x cube. And from the denominator, the maximum is 2. So I have taken 2 common, x square common. Now this will cancel down. It's giving you x in the numerator. Rest, it's 3 by 2. Now if you are having a number in the numerator and that is approaching to infinity, it becomes infinity. This is what I am telling you, that if the degree of numerator and denominator is same, you are getting the answer as the coefficient of the highest degree terms. But if the degree of the numerator is high than the denominator, then you will definitely getting it as infinity in case x is approaching to infinity. And similarly, you can see one more thing. Let me copy it again. Because this is a direct thing you can easily remember. Yes. Now let me change again. Suppose I'm taking 4 degree here. Now this is again 4 degree here. This will be x raised to power how much? It is 4 here. Is cube raised to power 3, and this is probably 4. No need to change a lot many numbers. Yes. How this is? Let's see. If the degree in the denominator is higher than the numerator, say cube in the numerator and 4 in the denominator. So I've taken the maximum common. Again, the same thing we are left with. And this is 0, 0, 0, 0. It's only 3 by 2. Now you can see here, cube 4. We left x with the denominator. That means something over infinity is 0. So if the degree is same, we are getting the coefficient as answer. The degree of numerator is higher than denominator. When x approaching to infinity, it becomes infinity. And if the degree of denominator is higher, and we are getting 0 as the answer. Now, this is very important concept when we are going to use the left and the right limits. Generally, when a function is defined as, say, fx equal to a particular number when x is greater than a, and what fx is equal to whatever the number is when x is less than a. In this case, we are going to use this left and right limit. And generally, one more is in case of modulus of x, the definition I have written here is if x is positive, it is kept as it is. If it is negative, we put minus x. And if it is 0, it's 0. You can add one more thing here, that is in case of greatest integer function also. In this case 2, we have to use this left and right limit. Now let me start with an example. This is limit x goes to 5 mod of x minus 5 upon x minus 5. Now being modulus, I have to use the left and right limit. So left hand limit is, I have put negative here. It's a symbol representing that I am approaching from the left hand side. That doesn't mean minus 5. X minus 5 upon x minus 5. Now, let's again see, yes, it can be done in the same window. Yes. If I am approaching from the left hand side, a number less than 5, let me suppose it is 4.9. If it is 4.9, what about 4.9 minus 5? Will it be negative or positive? 4.9 minus 5, it's negative. So if a number is negative, what is the value of mod x? This is minus of x. Whatever the number written here is, you have to put minus in front of that. The same I have done here. X minus 5, when x is approaching to 5 negative, I am coming from the negative side of 5, that is from the left side of 5. So this number in the bracket becomes negative. So as far as the definition is concerned, I put minus of x minus 5. It will cancel down, it will give you minus 1. Now when I am approaching from the right hand side, what happens then? If I am approaching from the right hand side, I have written positive here. Right hand side of 5 means say 5.2. What about 5.2 minus 5? It will be positive. If a number is positive, what is the modulus? The number as it is comes down. If it is x, it is x here. So the same I have done. It is x minus 5. I kept it x minus 5. So x minus 5 cancel down. The limit is 1. And I told you the limit in case of left and right should be same for the existence. But in this case, minus 1, it's 1. Left hand limit is not equal to right hand limit, so limit does not exist. Let us see one more example. Now this is the function defined as, for x less than half it is x, for x equal to half it is 0, for greater than half it is 1 minus x. We need to evaluate limit fx, x goes to half. For the left hand limit, left hand means less than half, I have to take this function. Now the functions are changing. Half negative means left hand side. The function I have used is x because this is less than half. So if you put half here, not minus half. Again I am saying you have to put the same value. Half means it comes down to half. For right hand side, greater than half is here. I have to use the function as 1 minus x. So positive is 1 minus x. If you put half here, it is 1 minus half half. Now the limits are same. That means limit exists and is equal to 1 by 2. Now this is one or two more formulas for limits. One is limit x goes to 0, 1 plus x raised to power 1 by x is equal to e. Other is limit x goes to 0, a raised to power x minus 1 upon x is equal to log of a. I use it here. Yes, one thing I want to emphasize here is, if it is x, you have, if you want to evaluate the limit, if it is x here, you need the reciprocal of this in the power. Say this is, suppose instead of you having this 2x, then to solve you need 1 by 2x. If it is say 4x, you need here 4x, then the direct formula will be applicable. Same is the case here also. If it is say 3x, you need 3x in the denominator. If you're writing as that a raised to power 3x minus 1 upon x will become log a, no, it won't be so. You need the same number, whatever is there in the denominator. Fine. Let me make the same result. Now, for example, this is limit x goes to 0, 1 minus 5x raised to power 1 by x. It becomes limit x goes to 0, return the same thing. Now, I have told you that whatever the number you are having here, you need the reciprocal in the power. So this is not x, this is minus 5x. So I need minus 5x in the denominator, means reciprocal. So what I do is I multiply the this power by minus 5 and divide by minus 5, so that these two numbers could be properly matched for the direct application of the formula. Now what about this? This becomes e. I write the formula here. This is e raised to power minus 5. Whatever we are getting this. Let's go for one more example of the second formula. The formula is written again here. This is ax minus bx upon x. Now the formula is ax minus 1 upon x. So what I do is I add and subtract 1 in the numerator. This is ax minus 1, minus is common. You can see minus minus plus 1, 1 will cancel down. So I have make a amendment here. I added subtract 1 in the numerator and numerator only. This becomes ax minus 1 minus bx minus 1 upon x. I separate the two numbers like this. Now it becomes a direct use of formula. This is log a minus log. One more example, that is for the greatest integer function. Yes. Greatest integer function is, suppose you are looking for the greatest integer of 2.3. Now if it is 2.3, you mark 2.3 in the number line. You need not to go beyond 2.3. Till 2.3, the maximum or the biggest integer you will be having is the greatest integer of 2.3. That is 2. So greatest integer of 2.3 is 2. Or you are looking for the greatest integer of suppose 3.7. What about greatest integer of 3.7? It will be 3 there. So this is the evaluate limit greatest integer of x for x goes to a, where the two parts I have taken. One is for integer, one is for non-integer. Suppose x goes to 2. I have told you earlier that in this case we will go for left and right limit. So when x approaches to 2 negative, 2 negative means a number less than 2. That is suppose 1.99. Now for 1.99, we need not to go beyond that number. Till 1.99, what is the greatest integer? 1. So the limit is 1. For 2 positive, means you are coming from the right hand side. 2 positive means say 2.1. Till 2.1, what is the greatest integer? 2. So the 2. And in this case, the two are not equal, so limit does not exist. In case we are approaching to a number which is non-integer, say 5.6. Let me go for the negative of 5.6. What will be the negative of 5.6? Say 5.5. Now for 5.5, what is the greatest integer till 5.5? 5. This is 5. For the right hand side of 5.6, the greatest integer is right side of 5.6. Let it be 5.7. Again till 5.7, the greatest integer will be having is 5. So limit will exist because they both are equal, and the limit value will be equal to 5. So this is the way you will evaluate all your problems on limits.